Hello and welcome back to Oxygen Not Included. Let's play episode 84. Let's get right into it. So, in the last episode I promised that we would talk a little bit about the sensor system that we have up here. Now there are a few different ways that you can tackle these sensors. The risk that you run a lot of times with these sensors is that if this air is a vacuum, you might not register a temperature in your system, right? And so you want to worry a little bit about that. That your system could be either too hot in that it boiled everything off, or it could be too cold and you don't have any steam in here and it's all just water, because we're going to vacuum out this area ultimately. Those are two different sort of failure modes for your build that you need to concern yourself with. And they both can be kind of severe. So you want to be thinking about that. There's a lot of different options. But another trick that sometimes works, depending upon what you have available to you, is you set up for yourself a little sort of temperature thermometer sensor type thing. So we could have, for example, an area encased in metal right here, and have some element in here that will boil at a higher temperature than the coolant that we're running through here. Well, not the coolant, the material we're trying to heat, in this case water, right? So we could put a little bit of petroleum in here, and if this petroleum changes phase, then we could send a signal, right? That's one way to tackle the problem. Another way that you can do things is just work off of the water levels in the room. Right, in this case, we are going to have a little bit of water in this room. In fact, now that I think about it, maybe that is the way I want to tackle it, in which case I want this to be just a little bit higher. I'd have to rebuild all this, which would be a pain though, so maybe we just avoid that. But we can have just a water level sensor kind of in a corner of the room that says, is there any water here? And use that to help guide our decisions on whether or not more water should be put in or less water should be put in. Another way to do it is that you just actually run the system, you figure out how well it's working, and you have valves on the side that control how much stuff is getting into your system. And then it's a simple matter of just tweaking things until they work on their own and continuing along with that. I am more of a proponent of sensors, because then you don't have to pay attention to them to figure out how to get your system to work, and if you make a modification to your system, then things will all still work. But there's a lot of options available to you from a lot of different sensors in terms of how you're going to get this all to work. But automation, we have atmos sensors that will detect the gas pressure, hydro sensors that detect the level, and the most useful of them is going to be a thermosensor here, which is going to tell us roughly the temperature in the room. So I think what we want to be doing is using, in this room, a combination of hydrosensors and thermosensors, and in this room just be using pretty much thermosensors, right? We're going to have a lot of oxygen in this room. We really just want to check what the temperature is, and we're going to check it, I think, at a lower point. So maybe I actually need this a little bit larger. Maybe not. And if the temperature is sufficiently low, then we're going to both run more oxygen in and pump some oxygen out. And we can let it get pretty cold before we do that. This steam, we want to let get pretty hot, I think. Having really hot steam is going to be nice, because this is ultimately going to be a way for us to delete heat in the long run as we send it to these steam rockets. Because I don't think that it matters what temperature you put the steam in at. Let's go ahead and have Stinky finish up as seasoned miner. No, he already finished that. Why does it say you have not finished seasoned miner? Alright, electrical engineer then is fine. We could move this pump up just a little bit and have liquid oxygen kind of pool on the ground. I don't mind that as a solution. Yeah, in fact, let's try that. Plumbing, liquid pump. We're going to stick this a little bit in the air, like so. And we're going to stick our sensors here. And let's go ahead and check what the liquefaction point. I've forgotten the term. Oxygen, when you turn to liquid. Negative 183 degrees Celsius. And then we have a window up to 218 degrees Celsius. Okay. So around 190 degrees Celsius, or negative 190 degrees Celsius, or maybe up to negative 200 degrees Celsius is where we're concerned with pumping this oxygen out. I think we're going to set it at the start to be very high, because the piping system, we want this next to our system over here, because we want our piping system to be very close. That way very little heat is lost in the process. So we're going to set thermosensors here. We're going to stick them down here. That way they are detecting the temperature of the liquid oxygen that is forming. Another job mastery, it looks like. Nails, done as a research assistant. Let's have you work as a gopher. Try and solve some of your problems. Oh, and Hassan is done as well. Was Stinky not done as minor? It just showed 100% that he wasn't done. Let's have you work as tenured scientist. Stinky, have you finished up? You know what, we're just going to let you finish that up. I don't really... We don't care too much at this point. They're all pretty good except for the new guys. Okay, so go back to automation. Let's grab a thermosensor. We'll make this out of steel, I suppose. We might as well. And this thermosensor is going to decide when we run this pump, and also it is going to decide when we pump in more fresh oxygen into the system. Actually, this is slightly awkward. We maybe just want a little bit more space on either side here. We'll make these rooms a little bit bigger. Making them bigger means that we actually have symmetry over here, which is kind of nice for my mental disabilities. But yeah, we're going to control, with this one thermosensor, we're going to control when new oxygen gets pumped in, and we're going to control when oxygen gets pumped out, right? Smart battery damaged. 125 degrees Celsius. How is that possible? Oh, because it's heating up because it has a vacuum in here. Because this is all done. Okay. Let's go ahead and disable this building and let this steam start to condense. We need to pump up some more water into here. Yeah. Okay, so this is run dry. This cool steam vent has not produced enough steam. We need to get some more water in here to condense this down. What are you waiting on? Anything? Let's go ahead and plumbing overlay. Let's go ahead and hook this up. Liquid pipe, igneous rock. Get a little bit more water flowing into here. You don't have any polluted water. That's right. I think we just want to... 6.1 degrees Celsius, 15... Yeah, when we're not running these metal refineries, this all becomes a little bit redundant. Maybe it's time to just say, look, we just want to connect these up. I could buy that. Let's just get some cold water pumping down here. What's temperature like? It's fine. We have so much water. I hate being inefficient, but we have so much water that I think it's time. Let's go ahead and say plumbing, liquid pipe, igneous rock is fine. Just go ahead and start dumping out water here. We just don't have anything else to do. Job mastery, Hassan, nails. Yeah, sure. And we'll get it pumping back up here. And everything will be Gucci. Okay. What was I saying about sensors? Yeah. So we're going to expand this out one tile. That way I have room for a vent. We're going to grab a gas vent. I guess we could make it a high pressure vent. I don't really want to do that though. Yeah, because we aren't interested in overpressurizing this room. We're going to create a gas vent here. And we are going to have a yeah, because now I actually have enough room for everything. Interesting. Alright, I think this is fine. So we're going to set up a sensor. A little thermosensor. Make this out of steel as well. And basically what this is going to do is when the temperature is below a certain point, we're going to tell this pump that it can run. Right? We should also, I suppose, say that the hydro level needs to be above a certain point, but we're going to have a separate thing. Right, just so that this pump doesn't run for no reason. That would be a little bit inefficient. Well, we're just going to tell it that it can run. We could put another sensor in here just to have the extra control. I don't think I care. Okay. I won the debate with myself. Congratulations. Yeah, so this vent is going to vent fresh oxygen into here. This is going to store our hydrogen coolant. This is going to pump out liquid oxygen. New dupes available. As we wait for the lag. Nope. Again, we're only selecting master race divers lungs duplicates. It's part of the stipulation. So this thermosensor, we're going to say if your temperature is below negative 190 degrees, then turn on. And by turning on, we are going to turn on this liquid pump, and it is going to start pumping out liquid oxygen into a container, right? We're also on a filter going to say, if you've received an active signal for long enough, start pumping in new, fresh oxygen, right? And so what's going to happen is this is going to start pumping first. It's going to start pumping out some liquid oxygen. And then after a while, this is going to kick in and say, oh, and you should start pumping in new, fresh oxygen. That is the plan. Now, setting up how long we delay is a little bit of a trick. It's going to depend a lot upon what temperature we set here, because we just don't want new oxygen warming this up to an extent that as we are pumping out, we're getting something that isn't that cool. But this filter could be very short, and in fact, probably is going to be nothing at the start, because we're going to have this set to a really, really low temperature. Ladders. This smart battery is broken because the system is empty, and that one's broken. Okay. Let's go back up to here. So we can have a filter and control and meter how fast we pump oxygen into the system. But because we're going to set this to be very cold, because we want this to be able to chill the pipes, we want to have a buffer. That way, as it's being pumped out here, it's not warming up and breaking the pipes. We're not going to really have to need much of a filter. So that's going to be our system here. And this we might as well deconstruct because we're going to build our liquid liquid reservoir. So why do we have this gas reservoir here, you might be thinking? I mean, we don't... The goal is not to cool down a whole bunch of coolant, right? The goal is to cool down this area. Isn't this gas reservoir just kind of taking up a lot of space? Well, the answer is that we want a little bit of an area for our coolant to mix, right? Having our coolant mix is going to help even out our temperatures and make this more efficient, right? And so that's what this gas reservoir is effectively going to be doing. It's just going to be mixing our coolant. We're not going to try and fill this up, though, is the important part, because we again, we're not interested in just cooling down a bunch of hydrogen. I mean, it's nice, but it's not really what we're looking to do, right? Ultimately, we could, if we build up later out of the system, we could say, look, if you're cold enough, instead of skipping this area right here, how about you go down to a hydrogen cooling facility and be our input feed for that? So you can build off of the system pretty easily. But for now, we're just going to leave things the way they are. Jobs mastered is why I paused. This is an old message. No, Ruby is done as an apprentice miner and ready to work as a regular miner, I suppose. Okay, so we have our gas vent where we're going to input gas, fresh oxygen. We have our liquid pump, which is going to pump out to here. This whole room is going to be very cold, so we don't care that the pipe is sealed. So we can go plumbing, liquid pipe, and do we want it insulated? Not really. We'll make it out of insulated rock, or insulated igneous rock, but we don't care too much. This will be out of ceramic, because once it comes out of here, we're going to care a lot about it being at the right temperature. But there we go. So that's going to be our connection there. Very simple. We are also going to toss down radiant gas pipe. I suppose we can make this out of steel. It's reasonably high thermal conductivity, but the point is going to be that we want to have a lot of transfer in this area, right? We want this coolant, as cold as it is, to deposit all this coolness into this area. So we're going to want to grab some radiant steel pipe, and we are just going to want to snake our way across here. Best way to do that, we could do something like this. Like so. And then we are going to have insulated gas pipe connecting up from here. In fact, maybe we need to deconstruct just little parts of this so that we can get up here. I think we can manage it over here. Okay. And then we are going to have our output, ventilation, radiant gas pipe. We are going to do basically the same thing. And we're going to say, look, come along over here. And go something like this, right? And then insulated gas pipe, ceramic, to come down to here. So this is going to be the loop that our hydrogen takes. We're going to need to fill this up with a little bit of hydrogen, but it's not going to take too much. We also want, I suppose, where's our gas bridge? We need something to keep this going effectively. I guess these gas bridges right here will take things in. I think this will flow the way we've set it up. So let's go ahead and deconstruct this ladder and get our last thermoregulator in here. Jobs master, that was Ruby. Sure. Telescope is idle, that's fine. Alright, this looks good. Regolith at 92 degrees. Let's go through here and dump anything. Get rid of this. 53, it's a little bit hot. 50s are fine. 60s a little hot. '40s fine. Let's get rid of the regolith here. Let's go ahead and get rid of the regolith here. Alright. Then we'll go and we'll say copy settings across here, and then sweep all this. Move this back into this this warmer area. We'll need to automate eventually. Okay, so explaining more of our system here. So this is our large coolant loop, right? There's going to be a little mixing area. We're going to have a little bit of excess hydrogen in these pipes. That way it will mix and the temperatures will even out over time between all the coolant that's moving around here, right? Let's go ahead and utilities, thermoregulator, another one out of steel right here. All right. So coolant comes up here. It's been cooled off because it's been going through these thermoregulators, and it's through insulated pipe, so it's not really heating up that much from the hot steam producing area that we have here. It's going to come up here. It's going to cool off a bunch because we're creating a bunch of radiant pipe and a bunch of surface area here, right? It's going to mix in here, and then it's going to send it back over here with a little bit of cooling on the way. And we have our sensor up that's going to determine when we run this liquid pump, and when we pump in new oxygen, right? When this is sufficiently cold, we're going to run this. And we should just have basically a floor of liquid oxygen, and then once it reaches this level, it's going to start going into this liquid pump, right? That's the goal. So we need to set up some automation for that as well. But that's not a huge concern at the moment. Let's go ahead and deconstruct this, and we will ceramic up this area now, and that'll seal this in. This should we want the room to be kind of small, but it doesn't have to be. I mean, this is still pretty large for a cooling room, but you just don't want a lot of thermal mass in here because you're going to spend a lot of your effort cooling down that thermal mass as a result. Yeah, having these rooms to be a little bit smaller is better. But we also have 3 thermoregulators going on here, so this is probably going to be a pretty quick process. And mainly we're going to be using this again to generate steam for our steam rockets, but it's also going to have this usefulness here, and that we should have ready to go a little bit of sorry, let me insulate liquid pipe, a little bit of liquid oxygen ready to go. So we're also going to run out this pipe right here, and we can connect this to stuff once we're set up. Okay. So there was a little bit more of our system shown off. Benny, what are you gonna do? You know what, general engineer is fine. Go work on that. I think I'm gonna cap the episode here, and I'll catch you guys in the next one.